make and use the lunar phases calculator. First of all, the important thing that we need to, first important concept, is that the position of the sun, the location of the sun in the sky, defines what time it is. In this situation, we have the sun high in the southern sky. This is essentially local noon. The sun rises at 6 a.m. We're going to assume a very simplistic model where the sun rises at 6 a.m. and sets at 6 p.m. and again is at the highest in the southern sky at noon. In between these points, we have the sun high in the southeast at 9 a.m. and high in the southwest at 3 p.m. The nighttime also has the sun in certain positions, and again we're talking about positions relative to this horizon here. Okay, so this is going to be our horizon, and obviously directly opposite noon is midnight, directly opposite 9 a.m. is 9 p.m., and further directly opposite 3 p.m. is 3 a.m. So wherever the sun is, that defines the time. Okay, the next concept that we need to look into is that spherical objects in space, in the region of the solar system, are always going to be half illuminated. For example, if I have an object here, it's half illuminated, here it's half illuminated, or here it's half illuminated. Regardless of its physical position, half of a spherical object is always going to be illuminated. Now, how we perceive the illumination of that physical object depends on the viewpoint of our observer. Okay, so from here, and this is a very poor eyeball, from here we see the unilluminated portion of that object, and so it looks essentially dark. From here we see half of the object illuminated, which makes sense. We're looking at it from this side. However, from here, notice that the previous image, that the observer saw the right-hand side of the object illuminated, but here the object is illuminated on the observer's left-hand side because, again, the observer's left-hand side is over here, so the observer sees that the left-hand portion of this object is illuminated. This is very similar to what we see in the waxing phases and the waning phases, where the waxing phases are illuminated on the right, the waning phases are illuminated on the left. We'll see that in just a moment. And finally, logically from here, when we're on the same side of the object as the sun, we see it fully illuminated. So, waxing phases, we're going to start with the new moon, where our observer here is looking at the unilluminated portion of the object. The next thing we do is we look at the full moon, where the observer is in between the sun and the object, so we see the entire surface of the moon illuminated. The first quarter shows us that right half of the moon illuminated. Again, that makes sense because we're observing the sunlight illuminating just the right-hand side. And then we fill in the gibbous and crescent phases as we transition from new to crescent to first quarter to waxing gibbous to full moon. Again, so these are all of the waxing phases. Now, in order to make this a little bit clearer, what we're going to do is we're going to flip it around. Whereas before we had the sun in the east, or west, I'm sorry, and the full moon rising in the east, we're now going to go 12 hours later with a full moon setting in the west and the sun rising in the east. And the reason for that is it makes the waning phases much clearer as to what's going on. So we're really looking at the waning phases of the moon in the sense of what we see in the morning. And again, we have a gibbous, third quarter, waning crescent, and new. And again, these are all illuminated on the left. So the important thing is that the waxing phases are illuminated on the right, and the waning phases are illuminated on the left. Okay. So what we're going to do is we're going to take those two diagrams and we're going to put them together. Okay, so that we see the sun and the phases of the moon all the way around the earth. And so here's our waxing phases. Again, new moon, waxing crescent, first quarter, waxing gibbous, full moon, and then we rotate the waning phases around so that they fill in the other side. And again, these are all illuminated on the left. Okay, it doesn't look that way given the position of the sun here, but if you have a question, go back to the previous slide and see how the waning phases of the moon are illuminated on the left. So we start off with this picture. This is the model that you'll need to be able to create for quizzes, for the first exam, and for the final exam. So you need to understand the geometric relationship with the sun here, the new moon here, the waxing crescent here, first quarter at this location, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent. Okay? Another thing to keep in mind is that cycling through all of this takes 4 weeks. So that's from the new moon to the first quarter is 1 week, from the first quarter to the full moon is another week, and so on. So every 2 phases is a whole week. Here we have the phases of the moon video. In this situation, we're observing the unilluminated portion of the moon. This is the new moon position, and we're actually experiencing a minor eclipse as the light from our sun is blocked by the moon. We move forward to the waxing crescent position, where the crescent is illuminated on the right-hand side. Now we have the first quarter position, where we're seeing half of the observable surface of the moon illuminated again on the right-hand side, since it is a waxing phase. Here in the waxing gibbous, we have most of the surface of the moon illuminated. Finally, we reach the full moon position. We have to raise it up above the camera position so that my head doesn't provide an eclipse. Full part of the moon is illuminated. The waning gibbous, so now the amount of light, amount of the moon that is illuminated is decreasing, it's waning, and we have the gibbous position here, again illuminated on the left-hand side at this point. The third quarter moon, where the part of the moon that we see, half of that moon is illuminated, again on the left-hand side. Finally, the waning crescent, illuminated on the left, and back to the new moon position. The next thing that we're going to use a virtual horizon. And in this situation, we have a rather glorified popsicle stick. We're always going to see the sun and the moon in the southern part of the sky from the Chicago region. So we have the south in the center, east to our left, and west to our right. So the sun and moon will be rising in the east and setting in the west. And again, remembering that the position of the sun relative to that horizon, relative to the east point, south point, west, relative to this horizon here, the position of the sun tells us the time. This is the lunar phases calculator. We have the sun here. The new moon is next to the sun with the earth in the center of the whole thing. Opposite the sun is the full moon. Then we have our first quarter moon, waxing first quarter, waning third quarter, and the waxing crescent and waxing gibbous, and waning crescent here. And then we have our virtual horizon that we'll be using. Stop. So we have a series of questions. The first question, the moon is high in the south at 9 p.m. What phase is it? So here we have a location. We know where the phase is. We know where the moon is, and we know the time. So now we have to use the lunar phases calculator to determine what phase is in that location at that time. The first question is that the moon is high in the south at 9 p.m. What phase is it? What we want to do is we have our virtual horizon here, east, south, west. We have the sun. We're going to put the sun at the 9 p.m. position. Again, keeping in mind that relative to the virtual horizon, this is noon, this is midnight, and this is 6 a.m., 6 p.m., 9 p.m. So here we have the sun at the 9 p.m. position, and we can read off of this lunar phases calculator that high in the southern sky is the waxing gibbous phase. Stop. The answer, as we saw, is the waxing gibbous phase. The next question is the waning gibbous moon is setting. So now we know the phase, we know where it is, it's setting, always again in the west, and the question then is, what time is it? So let's work through using the lunar phases calculator to determine this. Problem 2 states that the waning gibbous phase is setting, and therefore, what time is it? So first we identify the waning gibbous phase. We rotate it such that it is relative to our virtual horizon. It is at the 6 p.m. setting position. We then look at the location of the sun, and we see that the location of the sun, this being 6 a.m., 6 p.m., noon, that the sun is at the 9 a.m. position, which is the answer. Stop. And as we see, the answer is 9 a.m. Finally, we're going to take these two concepts and put them together with a third concept. We have the moon rising at 3 a.m., so we know the time. We know where the sun is. We know that the moon is rising, so it's in the east. So now we need to determine the phase of the moon. Once we determine the phase of the moon at this configuration, we need to determine what phase will it be in 1 week. So then we work our way 2 phases counterclockwise through the drawing to determine what the phase will be in 1 week. The final question states that the moon is rising at 3 a.m. But what phase will it be in 1 week? So we start with the sun at the 3 a.m. position. So again, it's halfway here between the midnight position and the rising position. So the sun is at 3 a.m. We see that the moon phase that is rising is the waning crescent. So it's a waning crescent phase. And in 1 week, we go 1 phase of the moon, 2 phases of the moon for a week. We see that the phase in 1 week will be a waxing crescent. Stop. And again, here we see the answer is the waxing crescent. Thank you for working with me on the Lunar Phases Calculator. I hope this was a help. Good luck on your quizzes and exams.